Welcome to our mock interview pro video for aspiring vibration engineers. Today, we're here to help you ace your interview by walking you through some key questions you're likely to face. Let's dive right in with our first question. Can you tell us about a time when you faced a challenging vibration issue in machinery? How did you handle it? This question aims to gauge your problem-solving skills and how you apply your technical expertise to real-world challenges. Here are some pointers to help you structure your response. Start by clearly identifying the specific vibration problem. Discuss the measurement techniques you use to gather data. Explain the analysis process and tools you applied to understand the issue. Detail the solution you implemented and how you executed it. Highlight the results and any improvements that followed. Let's look at a sample answer to see how you can put this together.
Once, I dealt with unexpected high-frequency vibrations in machinery. I collected vibration data using an accelerometer and performed an FFT analysis, which revealed shaft misalignment. I corrected the alignment and balanced the rotors, leading to a 40% reduction in vibrations.
By the way, we're only covering a handful of questions in this video, but I've prepared a free PDF with all 30 top interview questions for Vibration Engineer. It also includes example answers and tips to help you prepare with confidence. The download link is just below. Could you share an experience where you worked with a team to reduce system vibrations? What was your contribution and what was the outcome? This question evaluates your ability to collaborate with others and contribute effectively to team projects. Let's explore some strategies to craft your answer. Mention a specific project you worked on aimed at reducing vibrations. Clearly define your role and responsibilities within the team. Highlight the techniques or methods you used. If possible, quantify the impact of the project. Share any lessons learned or skills gained from the experience. Now, here's an example of how you might respond.
In a project at XYZ Corporation, I was part of a team tasked with reducing vibrations in an assembly line. My role was to conduct vibration analysis using FFT to identify key issues. We implemented dampers and modified support structures, achieving a 30% vibration reduction, which boosted product quality and reduced machinery wear.
Describe a time when you had to explain a complex vibration-related issue to someone without a technical background. How did you ensure they understood? This question assesses your communication skills and ability to simplify technical concepts for a broader audience. Here are some strategies for answering this question effectively. Identify a relevant situation where you had to break down complex information. Use analogies or relatable concepts to make the technical details more accessible. Divide the complex issue into smaller, understandable parts. Engage your audience by asking questions to ensure they follow along. If possible, use visuals or diagrams to illustrate your points. Let's take a look at a sample response.
During a project meeting, I had to explain gear vibrations to our marketing team. I likened the vibrations to a loud car engine, using that analogy to explain causes, performance impacts, and solutions. I paused for questions throughout to ensure everyone was on the same page.
Imagine you're working on a structure that unexpectedly experiences resonance during operation. How would you go about diagnosing and resolving this issue? This question tests your approach to situational problems and your ability to apply theoretical knowledge to practical situations. Here are some steps to guide your answer. Begin by assessing the structure's operational frequency and identify under which conditions resonance occurs. Perform a modal analysis to find the natural frequencies and problematic modes. Evaluate the effectiveness of current damping mechanisms. Consider redesigning components to alter frequencies away from resonance conditions. Implement real-time monitoring to capture operational data for further analysis. Here's how you might frame your response.
I would start by analyzing the structure's operational frequency to identify resonance conditions. Conducting a modal analysis would help determine natural frequencies and modes. I'd then explore redesign options to move these frequencies away from resonance zones.
A client comes to you with concerns about their equipment vibrating excessively and causing issues. How would you address this situation? This question evaluates your customer service skills, technical expertise, and ability to address client concerns effectively. Consider these steps when formulating your response. Begin by asking the client for details about the equipment and the nature of the vibration. Conduct a thorough on-site inspection to observe the vibration firsthand. Use measurement tools like accelerometers to quantify vibration levels. Identify possible causes such as misalignment, imbalance, or loose components. Propose a remedial action plan based on your findings and communicate it with the client. Let's see how you can put these elements together in a sample answer.
I'd begin by gathering detailed information from the client about the equipment and vibration occurrences. After performing an on-site inspection and taking vibration measurements, I'd diagnose the problem, checking for causes like misalignment. Based on my findings, I'd suggest solutions and collaborate with the client on implementation.
Before we wrap up, remember you can get all 30 questions, example answers, and step-by-step tips in a handy PDF. Totally free, just grab it below.